Hello guys, my name is Devin, my YouTube channel is DRG Bros, and welcome back to another learning video. Today, as the title suggests, I'm going to be teaching you about photons and light waves. So first, what I need to review is, I'm pretty sure most of you know what an RGB bulb is. Now an RGB lights is essentially the three different colors. So if you think to art classes, they say that the primary colors are red, blue, and yellow. But in light waves and RGB, it's actually green, red, and blue. And so with these colors, you can make all the other colors. Alright? So, first, before we start talking about some other things, I need to explain a few things first. So, there is a spectrum of light lengths, like light wave length, right? And so there's only this small section in here. That is what's known as visible light, right? And this is the light and the colors that we see. So if you were to look around you, what you're seeing is that range of visible light, and that goes from a red to a purple, right? Now, beyond the, somewhere out here is ultraviolet. I'm not entirely sure. I think X-rays are somewhere over here as well. But so that's about what it is. But so visible light is 400 to 700 nanometers. I want you to remember that, guys. 400 to 700 nanometers. If you remember one thing from this video, that's what I want you to remember. Visible light length is 400 to 700 nanometers. So if you took a meter stick, a little wooden stick that's a meter long, and you chopped it into a billion pieces, the size of visible light would be 400 to 700 of those pieces. That is the definition of visible light. Now, typically, there's three that I'm really going to address in this video, but only two are truly important. We have our red photons, which are the largest. They're on the 700 side. So we have these reds that are the largest. Then we have green, which is the second largest. It's in the middle, right? And that's near the middle. And then we have blues. Blues are the smallest. So this one is about this one is 700 nanometers. This one is, I'd say, somewhere around 550 nanometers. I'm not sure. And then this last one is about 450 nanometers. Okay. So now I'm going to turn to the everlasting question. Why is the sky blue? Right? So what we're going to do, and I'm going to solve that problem for you. So what we're going to do is we're going to take a model of the Earth, all right, and we're also going to take its atmosphere, all right, and we're going to draw a little person right here, and he's looking in this direction, okay? And our sun, he's facing away from the sun. Now, the sun gives off all kinds of light, but it also gives off mostly visible light, all right? And so it gives off these red photons into the atmosphere, these green photons into the atmosphere, and these blue photons into the atmosphere. And so what happens is I'm going to, for the rest of this problem, I'm going to ignore the green. But so the red particles are going to enter the atmosphere, all right? And they're going to, they don't bounce very easily. So what they're going to do is they're going to go into the atmosphere, and they're going to go right out like that. Right? But meanwhile, because visible light is the light particles that enter your eye, that's how you see color. But so these blue particles, they go into the atmosphere, and since they bounce better, they bounce off of the dust and water vapor and stuff in the atmosphere, and that bounces back into your eye. And that is why the sky appears blue. But now then, if that were the case, How does the sun look at sunset? Now, the only way this guy actually looks red as a sunset, you'll find, is if you're actually looking towards the sun. If you're looking away from the sun, it looks kind of like a purplish blue. But if you look towards it, it's an orangey yellow. So what happens is we have our little guy here, and this time he's facing towards the sun. Now what's going to happen is, so these red photons are going to come in, and they're going to enter the eye. Right? And so the blue photons, since they bounce more than the red ones, because they're going to hit the particles, and a few of the red ones are going to bounce off back into space. Although the blue ones bounce better, so more blue ones are going out of the atmosphere. And so your eye, like, more red photons than blue photons enter your eye. And that's why the sky is red at a sunset. It's honestly pretty interesting. So I think that's all I'm going to have for this video. I hope you've enjoyed. Please tell about our channel. We need more subs. So yeah, thank you very much for watching, and I hope I'll see you guys for another video. Bye!